All right, so today in the calculus course, we're going to be talking about derivatives. So jumping right in, a quick definition for derivatives. You can visualize it just as the slope of the tangent line of any particular function at a certain point. So, the tangent line is just basically the line that rests tangent to the slope, tangent to the function rather. So then the derivative of the function gives the slope of that line at any particular point. So the derivative of a function f at a is denoted by f with a quote, a single quote, I suppose, a, so I'll just call that the first derivative. So the first derivative is the limit as h approaches 0 of f of a plus h minus f of a over h. This can also be written if we express x as a plus h, which follows that h is equal to x minus a. So then when h approaches 0, x would approach a. So then we can rewrite this expression as the first derivative would be the limit as x approaches a of f of x minus f of a over x minus a. So these definitions of derivatives will work in finding the derivative of any differentiable function. And for both definitions, you should be able to factor out and simplify in order to avoid the undefined case of dividing a number by 0, because currently as they are, you would be dividing by 0, but you would be able to factor out for any continuous function that is differentiable. So differentiability, rather, is the ability to be differentiable for a function. So if the first derivative of a function exists, then it is differentiable. It is differentiable on a non-inclusive, so an exclusive interval, if it is differentiable on every point within the interval. So a function is not differentiable at a if f has a corner at a. So you can see this in a graph. F is not continuous in any way at a, which means that the right-hand limit and the left-hand limit do not equal the f of a, and f has a vertical asymptote at a. So if f is differentiable, then f must be continuous, but f is not necessarily differentiable if f is continuous. So those don't go sort of back and forth. It's only one way. So some rules for differentiation. If you differentiate a constant, then it will simply equal 0 just because it's not a function. So the variable rule is if the first derivative of x, for example, is 1. The scalar rule is if you have a constant multiplying a function and you want the derivative, then that would be equal to the constant multiplied by the derivative of the function. The power rule is that, so x to the n, the derivative of that is n x to the n minus 1. This kind of makes conceptual sense because if you think about differentiating, say, a linear function, then you would get a function of degree 0, so just a simple number. Addition and subtraction, so if you have two functions that are added or subtracted, then that is equal to the first derivatives of those functions added or subtracted. The product rule is a little bit more complicated, so f of x times g of x, all the first derivative of that is simply the first derivative of f of x times g of x, just normal g of x, plus f of x times the first derivative of g of x. The quotient rule is somewhat similar, so if you have f of x over g of x and you want to find the derivative of that, then you would just find the derivative of f of x multiplied by g of x, subtract the derivative of g of x times f of x all over g of x squared. And the natural logarithm rule, e to the x, the derivative is just e to the x. So that's pretty simple. Just some review for lines, because that will come in handy when we're looking at derivatives. Two lines with slopes m1 and m2, they would be parallel if m1 equals m2. If the slopes are the same, they'll be parallel. And they'll be perpendicular if m1 is equal to the negative inverse of m2. Same way, if m2 is equal to the negative inverse of m1. And just to note, the tangent line is perpendicular to the normal line. This is just a definition. So we sometimes have to look at limits of trigonometric functions. So there's just some identities that we have to keep in mind when we're calculating the derivatives. So for example, the limit as x approaches infinity of sine x over x is 1, and this is the same for the inverse. And the limit as x approaches 0, cos x minus 1 over x is equal to 0, which again is the same for the inverse. So here are just some derivatives of trig functions. These are just the first derivatives. So derivative of sine x is cos x. Derivative of cos x is negative sine x. The derivative of tan x is secant squared x. Cosecant x is equal to negative cosecant x times cotangent x. Derivative of secant x is secant x tan x. And the derivative of cotangent x is negative cosecant squared x. So an important thing to note is that these derivatives occur in cycles of 4. So if you have a large derivative, just divide the number by the number of differentiations. Divide the number of differentiations by 4 and use the remainder to calculate the derivative. Just a note before I move on. As I was going through this, I noticed a few small mistakes, nothing major, so just check back on the link below, and I'll just fix a few typos. So we'll go over a few examples in this video, looking at the definition of a derivative, the power rule, and the product rule. And then in the extra examples linked below, we'll look at the quotient rule, the limits of the trig functions, which we were just talking about, and derivatives of trig functions. But for now, we're just going to look at these ones. So to start, we'll look at the definition of a derivative. Sometimes we'll be asked to find a derivative based solely on the definition and not using any of those other rules that we talked about. So, for example, if we have f of x equals 4 over x, then we can find the first derivative. So we would do this using the definition of a derivative, which I'll write down. So this is simply the limit as h approaches 0 of f of a plus h minus f of a all over h. So then we can get started. So the first derivative would be equal to limit as h approaches 0 of, and then we just put this straight in here, which you'll see in a minute. So 4 over a plus h would be that f of a plus h. And then we go minus 4 over a, which is just f of a. This is all divided by h. So then we can simplify this a little bit just by finding a common denominator for those two in the numerator. So this would just be 4a minus 4a plus h all over a plus h times a all over h. And then once we expand this, then, and we'll expand and simplify. I won't go over in too much detail how to do that. That's just algebra. That would equal negative 4h over a squared plus ah. And then we can simplify again. Oops, sorry, this is all over h. And then we can simplify again by bringing that h up there. So this would be equal to the limit as h approaches 0 of negative 4h over h times a squared plus ah. And I wouldn't expand here just because this is the part where it will simplify. And that's very important, so we can get rid of those h's. And that would just leave us, of course, with limit h approaches 0 of negative 4 over a squared plus ah. And we can simplify this further since h is 0. Then that whole term would be 0. Once you get rid of the limit, of course. So this would just be negative 4 over a squared. And then we know our a is just x. So this would end up as negative 4 over x squared. And if you did that using the other limit, or derivative rules rather, you would end up with the same thing. So the next one, we're going to talk about the power rule a bit. So we want to find the first derivative of this function, f of x equals 3x squared plus 4x plus 1. And we know that if there are functions that are added, then they're just added in the derivatives as well, so we don't need to do anything special with this x squared or this x or this 1. So we'll just find their unique derivatives and add them again. So then the first derivative would just be So for this first term, what we want to do is take this 2, multiply it by the 3, and then take away 1 from the power, and that was one of the rules that we talked about, of course, the power rule. So 2 times 3, actually I suppose I'll just write it out. 2 times 3, x 2 minus 1, and then same thing here, plus, so we have exponent of 1, so it would just be 4x 1 minus 1, and 1 is a constant, so the derivative of that, would just be 0. So then we'd end up with f of x, derivative of f of x is 6x plus 4. So pretty simple. All right. Now we're going to look at the product rule. So for this, we're going to use just the formula that I discussed before. So our function is y equals u to the negative 2 plus u to the negative 3 times u to the 5 minus 5u squared. And instead of expanding and finding it like we did above with the power rule, we can use the product rule. I think it would be a bit easier in this situation, although you could expand, but that would leave you with a lot of terms. But you could check it as well through expansion. So the derivative of this is just the derivative of the first term, and I'm just going to write it directly in. So negative 2 in front, u, and then negative 2 minus 1 is negative 3, minus 3u, so take that negative 3 down, and negative 3 minus 1 is negative 4, and then multiplied by the second function, just regular, so u5 minus 5u squared, and then add the first function, just the normal, not the first derivative. So u negative 2 plus u to the negative 3, and then the derivative of the second function. So bring that 5 down, u, 5 minus 1 is 4, minus, bring that 2 down, 2 times 5 is 10, and then u, 2 minus 1 is just 1, so we can leave it like that. So then we can expand. So this will be equal to negative 2u squared plus 10u to the negative 1 minus 3u plus 15u to the negative 2, and that's just simple expansion, so foiling if you want to call it that. And then 5u squared minus 10u negative 1 plus 5u minus 10u to the negative 2. And I can see that there is a term that will cancel, so plus 10u negative 1 here, minus 10u negative 1 there. And then we can just add like terms. And that will be equal to 3u squared plus 2u plus 5u to the negative 2. All right, that was a lot, but we are done for today. I'd like to thank Loom and Google Keep, and of course my professors. If you have any questions, please let me know. And again, sorry about those little typos. I'll be sure to fix those in the post notes. So check back for that, and also check back for the extra example with the solution. All right, thank you.